straight to the questions because we are going to edit the videos anyway. So,
that's fine, yeah,
okay,
no problem.
Okay, so first question, why are you personally taking part in the iGEM?
Right, as far as experience goes,
Right.
it's the only placement summer project, whatever you want to call it, that you had a degree of autonomy. And it's the only one where you had to tackle problems such as like organising your lab and organising people. I didn't want one where I'd be... So I heard about it when I was in first year.
Right.
And the Glasgow team did particularly well that year and got the environmental prize.
Right.
And it was well, it wasn't that year, that was before I was there. But it was just interesting. I read about it and I was interested in how it worked and stuff. And I just thought it was a great experience for like a career in academia. I thought it would be the closest thing you could probably get to. And maybe it would help me decide whether that's what I wanted to do, sort of thing.
Oh, right, okay. No problem. Next question. How did you guys come up with your project idea for the team?
Right, okay, so we had a bunch of brainstorming sort of sessions, I think, like everybody did. We were talking about ideas, and when we actually applied to be part of the team, we had to submit an idea as well.
Right.
And so, the first couple of sessions we were talking about our ideas and developing them, see where there was room for improvement on any of the ideas.
Right.
And of course we were talking to our advisors and the areas that they're interested in, which ends up not being anything to do with what they're doing either, but there's a general interest in it.
Right.
And yeah, it's just sort of developed from little ideas, and we decided we were interested in biofilms, and then really it sort of progressed. We decided that we weren't interested in the actual, it wasn't really biofilms that we were interested in. At the end of it, it was manipulating the behaviour of the cells in a biofilm,
Right.
and being able to tightly regulate their behaviour, sort of thing. So it's broke down now into, it's refined even further.
I see.
That sort of thing.
I see, right. Okay, next question. Biotechnologies like genetically modified food has sparked some controversies in the past.
Okay.
So how do you think synthetic biology is different from that?
From genetic modification? Well, it's not really. It's a platform to be able to genetically modify things using a different approach. I think that maybe you could argue, and anybody doing work with genetic modification would probably disagree,
Right.
but it might seem to the general public that it's a lot more precise. It's what we're doing. If the biobricks have all been categorized and we know their function,
Right.
then when we put them into a system, we should know exactly what happens. It's maybe a lot more controlled than random mutagenesis or and then just looking for mutants. We know that what we've wanted has been mutated, but we don't know what else has been mutated. And if you're putting a system in that hasn't existed before, whilst it might be affecting stuff in the cell, maybe it appears to be a lot more targeted, focused.
I see. All right. Next question. What do you think is the purpose of iGEM in the field of synthetic biology?
I think that it's to spread the word more than anything, isn't it, really? I'd had no idea about synthetic biology, the field.
Right.
And it's this incredible field, and it brings a creative element, it's interdisciplinary. But I hadn't heard of it at all, and so it succeeded in that element.
Right.
And of course, they need a lot of people contributing to the register to be able to make it work at all. Now, I mean, there's problems with the registry, and but with that many teams working on that many parts, it gives a broad catalogue for anybody that's wanting to take things from it.
Right.
And of course, there's the method there of testing and refinement of the parts, which is which would be required with that sort of registry approach. Yeah.
I see. All right. Moving on. How do you think synthetic biology can be made more relevant in the society?
How can we make it more relevant? Well, I don't know. I think it's going to become more relevant.
Right.
I don't think it's a matter of us having to. I think that it's a natural progression of how we work currently. So, now that we understand these systems, complex systems to do with cell division, and there's not many big questions left like that.
Right.
And we understand the fundamentals of how cells function.
Right.
And we're at a point where we can use this, reiterate this engineering approach over and over again. But it really is, it's like this pinpointed, targeted approach where we can take specific systems. So why wouldn't you use that approach? Why wouldn't you you have a problem and you can develop a solution in an ordered, organized fashion, why wouldn't you use that? So it will become more, I know that it'll become more relevant.
I see. Okay. Just the last question. Some people are uncomfortable with the idea of using life as a technology. So what do you think about this?
Using life as a technology? Well, it's sort of, no, you know, I'm not arguing about the sanctity of life and whatnot, but when you're looking at a microbe, right?
Yes.
And there's a lab up in Glasgow at the moment that's making artificial membranes, and in fact he's trying to make the simplest form of life possible, entirely chemically, that receives a signal, processes it, and then has an output signal.
Right.
And for all intents and purposes, you know, that's a living organism. He argues that this is a living organism. So the thing is, though, that I don't think anyone would say that was.
Right.
It's just difficult to define what life is. You look at a bacteria, and it's a collection of chemical groups. And if in isolation, if you took lipids or if you took small pieces of DNA and stuff, people wouldn't have a problem with that.
Right.
So we need to try and define where is the problem? Where is it coming from? You know, what is okay and what's not okay. These things together, that's an issue, but in isolation, they're not. So I think that basically we need better communication to be able to get people to think about this themselves and come to their own conclusions, rather than saying, oh, you know, yeah, this is fine because of X, Y, and Z reason. You know, it depends on your heritage and your culture, your religious views, political views. But yeah, it's, you know, I personally think that you're working on bacteria and you're working on proteins, and you know, it's a chemical thing, fundamentally. You know, so I don't think that there should be any questions of whether you're.
Thank you for your time.
That was great.